Hi everyone, this is Ramesh Babu. Welcome back to my channel. Today I would like to discuss about the circular permutations and number of functions. In this number of functions, I would like to discuss about the one functions, onto functions, bijection functions. When two sets is given, how many one functions are possible, how many onto functions are possible, how many bijections are possible. That one I will discuss. First, I will discuss about the circular permutation. Now, in the previous classes, still now we discussed about the linear permutations only. That means the arrangement will be done in a line only. If the arrangement in circular form, then that permutation, then that arrangement is nothing but circular permutation. Here, circular permutation can be done in two ways again. So, one will be, here you can observe this, that will be depending upon the direction. This is clockwise direction. If I take in the anti-clockwise sense also, it will be possible. So, if clockwise direction and anti-clockwise directions are different, then that arrangement is called round table arrangement. If clockwise direction and anti-clockwise directions are same, then that arrangement is called hanging type arrangement. So, those two I will explain clearly here. You can observe this, that is only anti-clockwise sense and clockwise sense are different, then it will be seating arrangement. If those two are same, then it will be hanging type arrangement. Hanging type arrangement means we can take necklace, garland and beads, all those will be taken as hanging type arrangement. So, I will give the clear explanation about these two different circular permutation. So, first I will discuss about the first one. If clockwise direction and anti-clockwise direction permutations are different, just you can observe this. If I taken the four members, A, B, C, D. If I taken the four members, just you can observe this here. I will take here four members. I will take here A, here B, here C and D. So, just you can observe here, if I take in the anti-clockwise direction, the arrangement will be A, B, C, D. If I take in clockwise direction, the arrangement you can observe this, the arrangement will be here A, D, C, P. So, just you can observe like this, we can arrange here four different cases it will be possible. Those you can observe here. I will draw, you can see this. If I take an anti-clockwise direction, B, C, D, A. If I take an clockwise direction, B, A, D, C. Next, third case. If I take an anti-clockwise direction, C, D, A, B. And clockwise direction, C, B, A, D. Now, last one. So, if I take an anti-clockwise direction, D. If I take an anti-clockwise direction, DA, BC, and a clockwise direction, DC, BA. In these four cases, you can observe this. This is anti-clockwise direction. First one is anti-clock and second one is clockwise direction. So, in these four cases, you can observe these four are different cases. And here clockwise direction and anti-clockwise direction also the arrangement will be different. In permutation, the order plays most important role. So, here you need to observe that A, B, C, D and A, D, C, B are different arrangements. That's why here you can observe that here four different persons are there. These four different persons we can fill with four places. Can be arranged in 4 factorial ways I can arrange, but here four different cases are there that will be divided. So, clearly I can write here 4 factorial, I can write 4 into 3 factorial by 4. So, I can cancel here 4 I can cancel, I can write 3 factorial. So just you can observe here, this 3 factorial I can write like this also, 4 minus 1 factorial. This one it will be useful for formula, then I will explain. Just you can observe here. Every case you can observe here. Here I kept A will be first, then remaining 3% will be arranged in 3 factorial ways. Simple. Here B will be keep as it is, then remaining 3% will be arranged in 3 factorial ways. Like that we can arrange. That is also we can consider, but for this is the basic concept. So now, if 4 persons are arranged in round table, 4 minus 1 factorial. If n persons are arranged in round table, then it will be n minus 1 factorial. That one you need to observe that. If clockwise direction and anti-clockwise directions are different, then the permutation will be like this. Next, in the second case, you can observe this. If the clockwise direction and anti-clockwise directions are same, just you can observe here. If I take in here A, if I take in B, if I take in C, if I take in D. So I will take anti-clockwise direction. If I take an anti-clockwise direction, just you can observe here. The direction is A, B, C, D. A, B, C, D. Just how if we convert into clockwise direction, this same A, B, C, D will be converted into clockwise direction. So then you can observe this. This is anti-clockwise direction. You can observe here. This anti-clockwise direction, just I will rotate this one into, I will rotate this one. Just I will rotate this one. Just you can observe here. The clockwise direction will be anti-clockwise direction. So in this, just you can observe here. This is anti-clockwise direction. If you rotate this one, the anti-clockwise direction will be clockwise direction. Just you can observe this. This is clockwise direction. And this is A. A is same. And this is B. And this is C. And this is D. Just you can observe this. What is the direction? A, B, C, D only. If I rotated, just you can observe this. If I rotated, then what will happen? Anti-clockwise direction will be clockwise direction. And one more thing you need to observe that here direction also, here also A, B, C, D, here also A, B, C, D. That means clockwise direction and anti-clockwise directions are same. That means we need to consider only one, either clockwise direction or anti-clockwise direction. So therefore, the required arrangement will, if I taken 4 persons now, so 4 persons can be arranged in 4 minus circular permutation, 4 minus 1 factorial I can arrange. But I will take only one now, that's why I need to take 1 by 2. So answer is 3 factorial by 2. If I take an n persons, then it will be arranged in garland or hanging type, whatever it may be. So n minus 1 factorial by 2 is the answer if I take an n persons. So just you can observe here. If I take in the n persons can be seated in round table, obviously n minus 1 factorial. Next, if I take in the beads or any hanging type you can take. If I take in n different beads, if you are taken, then half into n minus 1 factorial. Half into n minus 1 factorial. So now we will do few examples, then you can understand clearly. Just you can observe this. First example, you can observe a round table conference is to be held between the delegates, 20 countries. In how many ways they can be seated if 2 particular delegates they may wish to sit together. So here how many delegates are there here? 20, from 20 countries 20 delegates are there. In this, 2 particular persons they want to sit together. So if you Remove the 2 persons, then how many members are there? 18 members. Now, sit together. Whenever sit together word is there, these 2 persons will be considered as 2 persons together. Together means we consider as 1 unit. That one you need to remember. If 2 persons together means 2 persons will be treated as 1 unit. So now total persons equal to 18 plus 1, that equals to 19 persons. These 19 persons we need to arrange in round table. So how many ways we can arrange? Required arrangement equals to 19 persons will be arranged in 19 minus 1 factorial ways we can arrange. But here 2 persons together, now those 2 persons will arrange themselves. So 2 factorial ways we can arrange. So answer is 18 factorial into 2 factorial is the answer. So option B is the correct answer. So here you need to use, if n persons arranged in round table, then n minus 1 factorial. This one you need to remember. Next. Here just you can observe here. The number of ways of arranging 8 men and 4 women around a circular table such that no 2 women can sit together. So first we need to arrange the 8 men. If you arrange the, here you can observe this. Required arrangement equals to 8 men we need to arrange in circular form. If you arrange the circular arrangement, then 8 men will be arranged in 8 minus 1 factorial ways we can arrange. But after arranging the 8 members, just you can observe this. I can take 1, 2, 3, 4, 5, 6, 7, 8. 8 men I arrange like this. After arrangement of 8 members, then how many gaps are there? You can observe this. 1, 2, 3, 4, 5, 6, 7, 8 gaps. In these 8 gaps are there. In these 8 gaps, we need to arrange 4 women. If we arrange the 4 women, how many ways we can arrange? 8p4 ways we can arrange. So in these 8 gaps, 4 women we need to arrange. 8p4 ways we can arrange. So the required answer is 8 minus 1 is 7 factorial into 8p4 is the answer. So option D is the correct answer. Like this way we can arrange. Next. Here you can observe that the number of ways that 8 beads of different colors be string as a necklace. No issue about that one. So here hanging type arrangement. If n beads will be arranged in n minus 1 factorial by 2. Only either clockwise or anti-clockwise we need to consider as only 1. So hanging type means we need to take only 1. So that's why here n equals to, given that n equals to 8 is given. So answer is 8 minus 1 factorial by 2. So that will be 7 factorial by 2. 7 factorial means 7 into here 6 into 5 factorial. 5 factorial value 120, we know that value 2. So just you need to cancel. Just if I cancel this one, 3. 21 into 120. If you multiply this, then it will be 2520 is the answer. Option A is the correct answer. Like this way we can arrange. Next. Here you can observe this. In this case, the number of ways in which 5 men and 5 women. So just you can observe this 5 men plus 5 women. And these two will be treated as 10 total 10 persons. So these 10 persons, 5 men, 5 women, 10 persons. Now 12 children can sit around a table. So that the children are always together. The children's wants, they want to sit together. So 12 children will be treated as together. Children together. Together means we need to treat it as one unit. Whenever together word is there, then you need to take one unit. So if it is one unit, total persons equals to 10 plus 1, that equals to 11 persons. These 11 persons we can arrange in round table. So if you arrange the round table, therefore required arrangement equal to 11 persons will be arranged in 11 minus 1 factorial, round table conference, 11 minus 1 factorial. After arranging the 11 persons, here 12 children are there, na? 12 children treated as one unit. Na? Now the children will be arranged in themselves. If you arrange themselves, 12 factorial ways we can arrange. So answer is 10 factorial into 12 factorial is the answer. So option C is the correct answer. Next, here you can see this. In this case, you can observe that garland can be made out of 6 red and 4 white roses. 6 red and 4 white roses of different sizes. So that all white roses come together. So all white roses come together means 6 red roses and 4 white roses. 4 white roses together. Here together means we need to consider as one unit. If I consider as one unit, therefore total units 6 red plus 4 white roses treated as one unit, na? So therefore it will be 7 units. 7 units will be arranged in garland. Therefore required arrangement equals to garland means 7 minus 1 factorial by 2. And here one more thing you need to remember, 4 white roses arranged themselves. So 4 factorial wells we can arrange. So it will be 6 factorial by 2 into 4 factorial. 6 factorial by 2 into 6 into 120 by 2 into 4 factorial means 24. So 360 into 24. It will be 8640. Option A is the correct answer. Like this way we can find out. Now we need to discuss about the number of functions. In this number of functions, just you need to observe that here we are going to discuss about the how many functions will be possible, how many one functions are possible, how many onto functions are possible, how many bijection functions are possible when 2 sets is given. Just you can observe here. Here set A containing m elements and set B containing n elements. Then the number of functions from set A to set B is n power m. N power m. Here B first we need to take, then A elements we need to take. Just you can observe this. Here you need to observe the one example we will discuss. Here you can observe here set A. Set A means here m equal to 5 elements and set B containing 4 elements. That means n equal to 4 elements is given. So the required functions, the number of functions equals to n power m. N power m means 4 power 5. So 4 power 5 means we need to simplify. 4 power 5 means here you can observe this 2 square power 5, that is nothing but 2 power 10. 2 power 10 means 1024 is the answer. So option B is the correct answer. Next, here you can observe this. Here the number of 1-1 functions, sometimes we called as 1-1 functions, sometimes we called as injections, don't confuse about that one. And the number of 1-1 function from set A containing m elements and set B containing n elements is npm. npm. Here you need to remember n value should be greater than or equal to m, that one you need to remember. So we will discuss one example, then you can understand clearly. Just here you can observe here. Set A containing how many elements are there? Set A means m value. M equal to 3 elements is given. And set B containing, set B means n. N equal to 5 elements is given. So now how many 1-1 functions are possible? So required functions means 1-1 functions equals to npm. npm means 5p3. So 5p3 means we need to expand 5 into 4 into 3. So 20 into 3, that will be 60. 60 means option B is the correct answer. So whenever set A and set B is given, number of 1-1 function means npm, that one you need to remember. N means the elements of B, m means the elements of A, that one you need to remember. Next, many one. Many one means total functions minus 1-1 functions, nothing but many one. So here you need to remember this concept, you need to remember. Total functions equals to 1-1 functions, 1-1 functions plus many one functions. Many one functions. So if you want many one functions, so 1-1 function we need to subtract from total functions. So many one functions equals to total functions minus 1-1 functions. 1-1 function. Just you can observe this total functions means n power m. 1-1 function means npm. Simply you need to apply this formula, then you will get the many one functions. So we will discuss one example. Just you can observe here the number of many one functions from set A. Set A means m. M value equals to 3 elements. And set B means n. N equal to 4 elements is given. So many one functions, we required many one functions. Many one functions equals to n power m minus npm. Total functions minus 1-1 functions. Total functions are 4 power 3 minus 4p3. 4 power 3 means 64 minus 4p3 means 4 into 3 into 2. So 64 minus 24, it will be 40. Option C is the correct answer. If you want 1-1 function like this, we can find out. Next, here you can observe that onto functions. You need to find out onto functions. Sometimes we call as surjections. And you need to observe set A containing m elements and set B containing 2 elements only. That one you need to observe that. Then it will be 2 power m minus 2, number of onto functions. Onto functions equals to 2 power m minus 2. So for this you can observe here one example we will discuss. Just you can observe here. Here m equal to A, B, C, D, E, 5 elements. And obviously n value equals to 2 elements only we required. That is no need about this one. But compulsory we need to take 2 elements only. So number of onto functions. Therefore number of onto functions equals to or by surjections. Surjections sometimes we called onto functions, sometimes we called as surjections. So surjection functions equals to 2 power m minus 2. So 2 power 5 minus 2. 2 power 5 means 32 minus 2, that equals to 30 is the answer. So option A is the correct answer. Next, number of bijections. Bijections means here observe this, if the function is 1 function and onto function, then it is said to be bijection. And here remember one thing, if you want to find out the bijection function, compulsory set A containing elements, then compulsory it will be equal to set B. So set A containing n elements and set B also n elements. Therefore, the number of bijections are n factorial. That one you need to observe that. So just we can go for one example. Here you can observe this. Just you can observe here. The set A containing A equal to, and that means n equal to 4 elements, and here this one also set B also again n equal to m, that equals to 4 elements. So therefore, the number of 1 and onto functions, 1 and onto functions we need to find out, then nothing but bijections. So therefore, bijection functions equals to n factorial. N factorial means already n value 4, that will be equal to 4 factorial. 4 factorial means 4 into 3 into 2 into 1, nothing but 24 is the answer. Option B is the correct answer. Now I need to discuss about the constant functions. Constant function means if you are taken input will be, if you are changing any input value, the output will be same. Therefore, here you can observe this. If you, for example, f of x equals to, I will take one example. I will take f of x value equals to some 10. If I change this x value, 1, 2, 3, 4 up to infinity number, if I change any number, the output will be same. That means, just you can observe here, whatever b containing elements are there, for example 10 is the b containing elements, so n equal to 10. If it n equal to 100, n equal to 100 we will get, like that you will get. So whatever it may be. So if you want number of constant functions, the second set B containing how many elements, that is nothing but the number of functions. Next, identity functions. Identity function means compulsory, if you are taking whatever one input, if you are taken, output will be same you will get. So that is nothing but 1 only. If you are taken 1, 1 only. If you are taken 2, 2 only. See, input output are same na. So that's why the number of identity functions will be 1. So these are the number of function discussions. So in next class I will discuss about the sum of the digits and palindromes I will discuss. So please subscribe my channel and follow my channel. Thank you.